So previously I was taking these photos with my Wi-Fi camera inside my Raspberry Pi. So taking one picture every 30 seconds. And today I'm gonna take a look on that. And my goal here is to make a time-lapse video out of that. So I did it before, a few days ago, but I'm gonna do it all today again and go through the process of it. So actually this file here is already revealing the date when I did it last time. So the way I'm gonna connect to my Raspberry Pi, which is at pi at this IP address. And I know that I am saving all the pictures to this folder. So if I list all folders, all files here, it's on the camera still subfolder. So if I run du and then this, I'm gonna have an idea of how many files are there, or rather, how many gigabytes. So there are 3 gigabytes of pictures. It's quite a lot of pictures, and I want to know how many files. So I'm gonna do this and then pipe it to this command called word count, then -l, so that it counts the lines instead of the words. So we have about 60,000 photos. That is a lot of pictures, And what I'm gonna do is I want to download all those pictures to my laptop. So I'm gonna, I have the Raspberry Pi, but to run the things on the Raspberry Pi, I'm gonna use the command FFmpeg. It's a open source tool. It's gonna be quite slow on the Raspberry Pi itself. So I'd rather download all the pictures and then work with them on my computer. So to do that, in fact, I already did it a few days ago. So I ran tar -c and then the name of the folder, and then I did output to, and then I outputted to this file over here. So I'm gonna actually go and use this file because it takes a lot of time to do this. So you do it like this. I'm not gonna do it now because it's gonna take quite a while. The Raspberry Pi is quite slow on that. But yeah, since I already did it, and then after this finishes, I would copy the file using scp and then pi at the IP address, and then I have to pass in the folder like this, and then do cstill.tar, which is the name of the file, and then dot, so it's gonna copy this file to my computer, which is also gonna take a while because it's gonna come through the Wi-Fi. Yeah, and it's kind of slow. So that also I already did. So I have the file here. I'm gonna use that. This one does not have 60,000 pictures. Rather, it has, I think. Well, actually, let's go ahead and count them. So I'm gonna use this file. So that's if you wanna copy it. If you wanna, If you do that, that's how you copy the files. I already have it here, so I'm gonna just extract this file. So I'm gonna do tar tf and then the name of the file, and this is actually gonna list all the files inside. So you can see there are a lot of files. It's all on the camera stills folder / and then the file names are like this. And this so the names of the files are the timestamps. So this is a timestamp. This is a Unix timestamp, which means the number of seconds that have passed since January 1st, 1970. Yeah, that's just how it works. So to extract it, I'm gonna run the same command, but I'm gonna change from TF to XF, and that should already create the camera stills folder here. And it's gonna take just a while, should be quick enough. And I'm gonna go to my other tab and, well, actually, yeah, I have my FFmpeg command there. All right, so I extracted everything. I'm gonna also list all the files here. So I created this folder. Yeah, lots of files. There are about 39,000 or almost 40,000 pictures. And yeah, I'm gonna work with them. So what I wanna do, as I said, is a time lapse. I wanna actually list the files. So what I'm gonna do is a time lapse. All right. So I have a lot of files. If I open it here, I will be able to look at each picture. Let me reduce this. And if I go scrolling down through each picture, there is not going to be a huge difference between one from the other, of course, apart from the timestamp up here. And the idea is that these pictures are in sequence. And the sequence is determined by this number by this timestamp. So this is the timestamp. And therefore, to make a time lapse, I will need a certain number of pictures per second. And it's also very important that they are in order. All right. So that's very important that they are in order. Otherwise, it's going to end up only with crap. So this is the command here that I'm going to use to create this time lapse. So this tool is called FFmpeg, easily installable in any system. And then I'm going to have a parameter called frame rate, which is how many pictures per second I want. So usually a movie would have about 30 frames per second, and 60 frames per second is like a more smooth experience. And then here are a few parameters about the input. So this regards the input, what is gonna go inside of FFmpeg, and this regards the output. So basically, what this is gonna do is gonna take a lot of files. It's gonna take a sequence of files, and it's gonna produce one video out of it. So a video file. So like here, MP4 video file. So that's the idea behind it. And here I'm telling I want a 60 frames per second video, and the input is you're gonna take the files from current folder / and then the name of the file is gonna follow a pattern. There is gonna be a sequence. So there are other patterns, but I figured that the easiest one here is to use sequence. So that means, and then there's this %d here, which is going to be replaced by the numbers from 1 to infinity or so. And yeah, that's input. So the thing here is that I have to prepare these files. So you see the files here, they won't work right away because these numbers, they are not in sequence. I mean, they are in sequence in the sense that the timestamps are always growing because time is always moving forward. But there is a gap, like there's usually a 30-second gap. So you see this number minus this one is 30 because it's 30 seconds. And this one minus this is 30. And actually the difference should be 1. For FFmpeg, it should be 1. It should be like file 1 and then file 2 and 3 and 4. Because once it hits, like it tries to read file number 5, and then it sees that a file does not exist anymore, it's going to interpret it as being the end. So no more files. So I cannot have any gaps in there. All right. And this concerns about the output, and this is just, so this is not so important, but just saying use the codec called h.choose64, and here's the preset, which is about the, is going to end up defining the size of the video file being outputted. And faster just means the file size is going to be bigger, but this whole command, which can take quite a while to finish running, is going to be faster. All right, so usually when working with video, if you want to spend more time encoding, decoding stuff, you also actually decoding, but producing a video file, if you invest more time into it, like more CPU time and stuff, you're going to end up with larger file, with smaller files. And if you want to do things fast, you're going to end up with bigger files. That's because you can use more time compressing the video file. Or if you use less time, you're going to have a bigger file. Anyway, what I'm going to do now is I want to prepare all these files for this naming format here. So the way I'm going to do it is I have this camera stills folder, and I'm going to create a new folder called, let's say, CN. So I was using CN just because. And I'm going to use Ruby for this. So I'm going to run IRB, and I'm going to use it right on here. I'm not going to write a Ruby file. I'm just going to write Ruby code right away here on the REPL. So what I will need here is, well, first I want to require time, and I want to require date because I'm going to be working with them. And I want to list all files. So in Ruby, I can do this by invoking dir and then saying camera stills slash pick, and then it's kind of a pattern here, right? So pick and then anything and then .jpg, and I'm going to assign this to a variable called files, and I'm going to put new in the end, otherwise it's going to try to print. And I just want to check a few of them. Yeah, there they are. All right. So what I want to do, I have all the file names inside here. So if I type in files.length, I'm going to have 39,915 files. Actually, not the file content itself, but only the file names. But that's what matters now. And the idea is that I'm going to take all these files, and I'm going to copy these files to a different folder. That's why I created this CN folder, because I'm going to copy the pictures inside there, and the name or the file naming inside this other folder is going to follow this pattern. It's going to be file underscore and then a sequence from 1 to however many pictures I want .jpg. All right, so the first thing I want to do here, first thing is, I know I have this amount of files, so I want to put this somewhere. Num files equals, or let's say num pictures, or even num frames, because that's how many frames in the video is gonna have. So files.length. All right, so I have the number of frames here. Now, next step I want to do is I need to do. I don't know the order, so this is dir command here, return all the file, that's fine, but I need them in order. So I want to order by this number, because there's no guarantee that this is ordering them by like from the lowest number to the higher one. And then I want to do that. So the way I'm going to do is I'm going to extract this number by using a regular expression. So I'm going to do it like this. I'm going to do it with one file before, and then I do it after for. So pick, I want to capture pick, and then the plus, and then the final dot. I'm going to do this for one file, and here I have already the number. So easily extracted with this regular expression, extracted the number, this number from the file name. And now I want to do this for every single file. All right, so I'm going to put them on a variable called f. So f equals files dot, and then Ruby can help us here. There's a function called sort. I think it's sort by, and then you pass a block, and it's going to pass every single file name here on x. Therefore, I want to replace this with x. And what this does is that it is gonna like temporarily in memory create a new array, so to say, and the contents of that array is gonna be the contents returned by this block, and then it's gonna sort the original array based on these contents. So it's gonna sort these numbers, but in the end, it's gonna sort the file names. Does that make sense? I hope so. And well, let me take a look on this. So here I have, and I know for sure that they are in order. So when, I want to know when is this. So time.add, this is April 3, and then I take the next one. This is, I don't know why there's a 8 minutes gap here. But anyway, I'm not going to bother with that. The important thing is that this time is more in the future when compared to this one. So, all right, so I have all my file names in order in this f array. And the name of elements here is, of course, the same as my num frames variable. So now, before copying the files, I actually have something I have to decide, like I'm gonna create a time lapse. And if I think about it, if I take the first one here, so the first one, the date is this one, so that's April 3rd, about noon, about 1 p.m. And I want to also know the latest, so the last. What is the time of the last picture there? So it's 17. So it's 14 is almost exactly 2 weeks after. So this is 2 weeks worth of pictures. Almost 2 weeks. And now what I have to decide is how long my time lapse is going to be. So I'm going to make a 3 minutes time lapse. It's going to be 3 minutes. So I'm going to do some math here. So I'm going to have to put 2 weeks worth of pictures, 39,000 pictures, in 3 minutes of video. All right. So remember here, I can choose the frame rate of my video, and I'm going to choose 60. I could choose 30 would be fine. Could choose, so 30 is kind of usual, or 24, 25 frames per second is fine. If you go much lower than that, like 10, maybe the video is going to be a little bit weird. So yeah, 60 is going to be super smooth, and that's what I want to go with. And so I think I have to think in a certain way. So I have 3 minutes of video, and each minute has 60 seconds. So in total, my video is going to have 180 seconds. And each second, since the frame rate is 60, each second is going to naturally have 60 frames. And this is going to calculate the amount of frames that the final video is going to have. So I have here 10,800 frames in a 3-minute video. So any 3-minute video, I hope you can see that, is going to have this amount of frames in it, if the frame rate is 60 frames per second. All right, but I have much more pictures than that. So I have almost 40,000 pictures. What do I do? So you see there's a problem here, right? I cannot fit all these pictures inside this number. So the problem, there's a problem here. So I could either increase my frame rate so that, let's say if I increase the frame rate to, I don't know, 90, not enough, 100. I don't know, I could keep increasing my frame rate. So that's getting close, maybe. That's too much. Yeah, this is already about, so if I would have a frame rate of 220 pictures per second, yeah, maybe it would then fit all my frames, all my pictures, but that doesn't make any sense really. There's no point in making a video with such a high frame rate. Nobody is able to see 220 pictures in 1 second. Doesn't make sense. So what makes sense is 60. But then we have less frames. I could also extend the length of the video, but what I'm gonna do is I'm just gonna drop frames. And by that, I mean, I'm gonna throw some pictures away. I'm not gonna use every single one of those, all right? And now the decision to make is which pictures are gonna be included and which ones are not gonna be included. So I'm gonna actually take this number here and put in the in a variable called output frames, which is the number of frames in the output video. And I wanna now, so I'm gonna end up copying this exact amount of files. So I'm gonna count from 1 to output frames. And I have to do it like these 2 dots. Yes. So this is gonna count, if I put it in a loop, is gonna iterate this amount of times with I varying from 1 to this number here. All right. And I wanna map. I wanna map this to a file here. So this is basic mathematics, and what I'm gonna do is I'm gonna take this I, convert it to float, and then divide it by output frames dot to f as well. And that means that this value inside parentheses here is gonna be a number between yeah, actually I wanna change this just a little bit. Instead of putting 1, I'm gonna put 0. And then I'm gonna add another dot here, so it goes to output frames minus 1. That means that this value here is gonna vary from 0 to 1. So it's gonna be numbers between 0 and 1. And then if I multiply this by f.length, which is also what's stored in the variable numFrames, which is the total number of frames that I have available, right? So all the pictures I took. This is gonna end up varying from 0 to 39,914, not 15, 14. I need 14, otherwise is gonna go beyond the bounds of the array. So I have a problem. I think I have a problem. No, I don't have a problem, because actually this is not going to vary from 0 to 1. This is going to vary from 0 to almost 1. It's never going to reach 1. It's going to be like 0.99999 something. So it's never going to be 1. Therefore, this number, well, let me actually go ahead and put this in a variable called indexes. And then I'm going to do a map, and yeah, that's it. So indexes, I think the correct name would be like indices. So indices 0 is naturally 0. Oh, I forgot to convert this to an integer again. And when I use this method, so no, it's not ceil, it's floor actually, if I want a floor, which is gonna always convert it to the lower number. So for instance, 4.9999.floor is 4 and .ceil is 5, right? So here are my indices, and the first one is going to be 0, then 3, 7, and the last one is going to be 39, 9, 11. That's a funny number. Yeah, anyway, that is fine. And what this thing actually is the index. So these are indices that are going to be used in the F array. So I'm going to go now through each one of these indices, and I'm going to access it. I'm going to get the file here. So I could map if I want to choose. So these are the pictures that are going to be included in the final video. These are going to be the pictures. All right. So this I here is varying from 0 to about 39,000. And actually, I want to do something a little bit different here. I'm not going to use a map. I'm going to use each with index. And I'm going to have two variables here. So f index and then picture number. Let's say picture number. And then I want to put that picture number is going to be the f index. I'm going to put a new so it doesn't print out everything. And if I run it, I know that, so I'm going to have 10,800 frames. And here I'm starting with 0. So let me actually clear this and print it again. And what I'm doing here, I'm saying that the first frame, so let me actually add a +1 here, because in the end, that's what I'm going to be using. I'm going to say, so remember that the output video is going to have this amount of frames. And here I'm mapping from the input to the output, or rather from the output to the input. So the first frame of the video is going to be the frame number 0. So in the array. So among all these pictures, 0 is like this one, the first one, right? And then the second frame of the output video is going to be the frame number 3, which is the fourth one, since we are starting with 0 here. So 0, 1, 2, 3. So that means these 2 frames are going to be skipped. They're going to be thrown away, not be included in the video. But think about it. This is 0, 1, 2, 3. So there's not a lot of difference here. Nothing really going on here, and we don't have a problem losing them. All right. So yeah, this is the mapping. So I hope you got the idea there. And then the last frame is going to be this input file. And what I'm going to do here now, instead of printing all of this, well, I can print it. That's not a problem. But I want to copy these files. So I want to copy these files from here, from this folder, into my new CN folder. So I'm going to end up with all the pictures inside this. And the naming of the file is also going to change, and it's going to be from 1 to 10,800. And the way to do that is, let me open Dash, which is the documentation software I like to use for Ruby. Yeah, it's already here. So Ruby has this module called file utus, or however you pronounce that. And it has this LNS method. So instead of copying the files, I'm not actually going to copy them. I'm just going to create a symlink, or a symbolic link, which is kind of a shortcut in Linux systems or Mac OS as well. And then I'm not going to waste more space of my disk, because it's not going to actually copy the file contents. It's just going to create a shortcut, and FFmpeg is totally able to read that shortcut, and it's not going to be any slower nor any faster as well. It's just going to be the same thing. So yeah, I have to print this because I need to require this module first. And then let me clean and go to, I'm going to say that, well, let me put the input input file is going to be f at position f index, and the output file is going to be cn slash, and then I think is file underscore, so file underscore, and then the pic number +1 dot jpg. All right, so I'm gonna also change this here and say output file. So input file, and I'm gonna print that. So yeah, so this file is gonna be copied, or rather sim linked to this file. So doing that should be easy because it's just calling this function. And the order of the parameters here is a little bit weird. That's just the way Linux works. So the target is the first parameter, and then the source file is the second parameter. All right. No, wait. The target is the file we are targeting. Yeah. So this is going to create the file link that is going to point, this is going to be a shortcut to this file here. So this is actually the input file, and this is the output file. All right, so let me go back here and run this command again and say file choose.lns, and the target is going to be the output file. No, the target is going to be the input file. I'm always confused by this because the target is the file that already exists, and therefore the second parameter is output file. And well, I'm going to run this. This is going to create a lot of files. It's going to take a while. All right. So now if I come here to my CN folder, I can see all the files here. And they are in order, ready to be fed to FFmpeg. You can see the size of every file is 32 bytes, actually just because this is a shortcut. All right. And I just realized I made a mistake here because this does not make sense. So this file, and let me actually open a new tab and do this listing here of the CN folder. So you see that this file is pointing to camera stills and then the file name. That's fine, but it cannot locate camera stills. I have to pass in the whole folder name, or I have to go like / camera stills, because if I am on the CN folder and I try to access the folder called camera stills, there's nothing here. But if I go back one path, then I can find the files there. Or I could specify the whole folder, like the complete folder structure. If I go here and I type in pwd, this is the absolute full path name. But I think using .. is going to work. So what I have to do now, I have to fix this, and I have to remove every single file from here and generate them again. So I just need to change the output file, which is going to be actually the input file. Input. So I'm going to change it directly here. And I'm going to put this. All right. So it created files, and if I try to access it now, it opens. It actually opens the picture. All right. So next step is to go to the CN folder and run this command. So I'm going to go into the CN folder and run, and that's going to be FFmpeg frame rate 60 pattern time sequence file, and then this, and preset faster, and I'm going to output this video to Timelapse, let's say 01 lapse. And this is going to take a while. I'm even going to add the time before so that it measures how much time it took to create this time lapse. And I'm going to run it. All right, so it's almost finished, and it's finished. So All right, and it took 3 minutes and 20 seconds to finish it. Cool. So now I have my video. Now I want to check it out. So it should be in the previous folder called Timelapse 01. You can see the video size is 145 megs. It's quite large. So play it. And there you go. So nice, it works. I'm gonna put the video, I'm gonna append this whole video to the end of this very video, so you can watch it all if you want. Also, I want to comment a little bit about this, because if you look at it, you can see that it's kind of, the lights are kind of flashing, right? So this is nighttime. This camera has a, I don't know, it sees when it's night. I think it's a UV camera, no, infrared camera. Yeah, anyway, it's gonna be black and white instead of colors. But here during the day, you can see that it's very flashy. So I didn't account for that when I made my setup. Well, it's also a security camera, so it's I mean, it's very simple. You cannot program it a lot or configure it a lot. So I think I would not be able to make the light exposure thing constant. Yeah, anyway, then I end up with these artifacts in the video. So it's kind of flashy, yeah, not very good quality, but yeah, that's enough for what I want here. I would need a different camera in order to improve this quality. But yeah, this is enough for the time-lapse thing. And that's also it for this video. So now I will keep you with the whole time-lapse. And thanks for watching. See you next week. Goodbye.